Today, we will answer this geometry challenge. And here's the question. Given this triangle, now let's trisect the base of this triangle like this. And from this vertex, let's draw a segment that cuts this triangle into some ratio. Now the area of this triangle, this blue triangle, is 6 square units. And the area of this quadrilateral right over here is 11 square units. And of course, the question is, what is the area of this green triangle? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. The answer to this question, or the area of this green triangle, simply equal to 2 square units. And that is the answer to this question. And of course, the main question is, how do we get this result? And here's the solution. To answer this kind of question, first thing that we need to do is to replace this question mark with the variable x. In short, if we get the value of x, then we're done. That is the area of the shaded region, or the area of this green triangle. And now, let's focus on this figure. And in order to get the value of this variable x, we will use what we call the ratio of areas. So this tells us if we have two triangles having the same height, therefore, the ratio of their areas must be equal to the ratio of their bases. And that is the concept that we need to use to answer this question. In order to use this concept, we will use the fact that the base of this triangle is divided into 3 equal parts. So first thing that we need to do is to connect this point to this intersection like this. Now, these two triangles, since they have the same height and the same base, therefore they have the same area. So the area of this yellow triangle is also equal to 6 square units. Now, another thing is, let's connect this point, this vertex, to this intersection. And let's focus on these two triangles. Now, the ratio of their bases is 2:1. Of course, they have the same height. Therefore, the area of this blue triangle is 2 times the area of this yellow triangle. Now, since the blue is 2 times the area of this triangle, this yellow triangle, why not, let's call this unknown part be equal to 2y. Why 2y? Because the total area now of this blue triangle is 2y plus 12. In short, half of it simply equal to y plus 6, or 6 plus y. Now, we know the total area of this quadrilateral is 11 square units. Therefore, this triangle on the top must be equal to 5 minus y. So 5 minus y plus 6 plus y, this becomes 11 square units. Alright, now, let's focus on these two triangles. They have the same height for sure, and they have the same base. Therefore, they have the same area. So the area of this yellow is x plus 2y plus 6. In other words, the remaining area, or this triangle right over here, simply equal to x plus 2y. So this triangle must be x plus 2y plus 6 also. Now, how about this triangle on the left side? We have 11. In short, the triangle, the area of this triangle on the top must be equal to x plus 2y minus 5. So the total area of this triangle on the left side is also x plus 2y plus 6. Now, from here, let's focus on this figure. And let's call these 3 segments as segment A, segment B, and segment C. Because again, we will use, again, the concept of ratio of areas. Now, from here, let's consider the ratio of A over B plus C. In our figure, this is the 2 triangles that we are interested in. So the base of this blue is A, and the base of this yellow is B plus C. In short, we can say A over B plus C is equal to x plus 2y minus 5 over 2x plus 2y. On the other hand, on the bottom part of this figure, we also have A over B plus C. So A over B plus C is also equal to 5 minus y over 3y plus 18. So this must be our equation number 1. Now, another ratio that we are interested in is the ratio of B is to C. Now, B is to C is also equal to these two ratios, x over x plus 2y on the upper part, and on the bottom part, we have 2y over 12. Now, if we get the value of x given these two equations, we can now solve this problem. And that's what we need to answer this question. So let's focus on these two equations, but let's focus on the first equation. Now let's simplify this. Cross multiply, multiply both sides, and combine like terms. This will give us 5xy plus 8x plus 8y squared plus 11y minus 90 equals 0. That is our first result. Now the second, let's have the second equation. Now 2 over 12, this will give us y over 6. Cross multiply. Now isolate the variable x. This will give us x equals 2y squared all over 6 minus y. So this is the second result. Now let's combine the first and the second result. And in order to solve for the value of x, let's replace all x with 2y squared over 6 minus y. So our equation now becomes like this. So this equation is in terms solely with y. Now simplify this equation and we get 2y cubed plus 53y squared plus 156y minus 540 equals 0. This is a cubic equation and we can use a lot of method to factor this. And once we factor this cubic equation, we get these factors: y minus 2 multiplied by y plus 6 multiplied by 2y plus 45 equals 0. In short, the values of y are 2, negative 6, and negative 45 over 2. But take note, variable y is also represents an area. In short, cannot be a negative number. So, y equals negative 6 cannot be the value of y, and also negative 45 over 2. So what we need here is the value of y equals 2. Now, we know the value of y equals 2. In short, we cannot get the value of x. Now, let's get the second result, and let's replace all y with 2. So I have 2 times 2 raised to the power of 2 over 6 minus 2. This will give us 8 over 4, and 8 divided by 4 will give us 2. In short, this variable x simply equal to 2, and the area of this green region simply equal to 2 square units. And that is our answer to this question. Therefore, given this figure, then the answer simply equal to 2 square units. And as always, we are done.